If x over 24 is equal to 4 over x plus 3, what is the value of x? If we first reduce this, it'll be 1/3 4 over x plus 3. And then if you cross multiply, it'll be 12 and x plus 3. And therefore x is equal to 9. Let a, b, c be non-zero digits so that bc is a 2-digit positive integer and abc is a 3-digit positive integer made up of the digits abc. Suppose that bc plus abc is 876. What is the value of a plus b plus c? Well, let's concentrate on this guy right here. That looks to me that 3c is 6. Well, immediately that means c could be 2. There's a few other possibilities, like you could be 16 and you carried the 1, but let's just go with 2 for now. Now let's look at the next, column. That would be that 3b is 7. Now 3b 7 probably is not what is the scenario, because a, b, and c are digits. And it even tells you that. And that means if 3b is 7, b would not be a digit. So what I think is maybe 3b is 17 and you carried the 1. But then again, you face the same problem. B would not be an integer. It would not be a digit. So how about 3b is 27? I think that is what would make it work, and it does. B becomes 9. Okay, so now we're down to this guy. But remember, it's 27, so we had to carry the 2. Don't forget about that. So that would be 2 plus 2a is this time equal to 8. And if that's the case, then this is solved with a equals 3. So that means a is 3, c is 2, and b is 9. And you can, put this substitute these numbers in to kind of verify that this is indeed going to be 876. And it is. It works out perfectly. So then what did they want? A plus b plus c. So a plus b plus c is 3 plus 9 plus 2. And that, I believe, is 14. A 5 by 5 flat square roof receives 6 mm of rainfall. All of this water and no other water drains into an empty rain barrel. The rain barrel is in the shape of a cylinder with a diameter of 0.5 meters and a height of 1 meter. Rounded to the nearest tenth of a percent, what percentage of the barrel will be full of water? So we have the base, which is 5 by 5. And it's meters, so we're going to have to do some currency, some measurement conversions, because we got meters in here, we've got millimeters in here, and I'm actually going to convert everything to centimeters, but it doesn't really matter what you convert it to. Okay, then I draw that little up and down, vertical to represent the 6 mm height of the rainfall. Okay, so what are we trying to do here? The rain, I guess, in centimeters, the volume, volume in centimeters would be 5, but it's 5 meters, so 500 centimeters times 500 centimeters, and then 6 mm, but in centimeters that would be 0.6. So that basically, whatever that number is, that represents the volume of the water. And then what they're doing is they're putting that water into some cylinder here. And that cylinder, they've given us dimensions. The height is 1 meter, and the diameter is 0.5 meters. Now, the volume of a cylinder is pi r squared times the height. So the diameter is 0.5. So the radius would be half that, so 0.25 meters, but in centimeters, that's going to be 25. And then the height is 1 meter. In centimeters, that would be 100. So there we go. I think that pretty much is all we need to make the comparison now. So the percentage will be the volume of the water, which is this guy. So 500 times 500 times 0.6, and then of course we're going to compare to the volume of the cylinder, which is pi times 25 all squared times 100. And when you do this, I believe this is 150,000 1,000, and then this is 196,250 approximately, using 3.14. And when you do this math, it's about 76.4% rounded to the nearest tenth of a percent. Determine all values of x for which 2 times 4 to the power of x squared minus 3x all to the power of 2 is equal to 2 to the power of x minus 1. 2 times 4 to the power of x squared minus 3x, all of this is squared, and that is equal to 2 to the power of x minus 1. Okay, let's see what we can do here. So this 2 I'll leave alone. This 2 I will just write it as 2 to the power of 2, and this is x squared minus 3x. And let's not forget that it's all squared. And then at this point, I'm going to keep that 2. This 2 I will apply to that, so it will become 2x squared minus 6x. And this is basic exponent laws. I'm not doing anything, no tricks, no magic, nothing. And then this is 1. So again, using basic exponent laws, let's see, what will I do here? Well, I guess I can just square it, right? Yeah, using this guy. So this just becomes 2 to the power of 2. This becomes 2 to the power. You multiply by 2, actually. So that would be 4x squared minus 12x. And then this doesn't change. And then now using exponent laws, we have to add them. So it's 2 to the 4x squared minus 12x plus 2. And that's about as far as I can go. Now that the bases are the same on both sides, that means the exponents are the same, so that means this is equal to that. So that basically means that 4x squared minus 12x plus 2 is equal to x minus 1. Okay, so that we're in a little bit more, I guess, digestible territory. And now we can just put it all on one side. So 4x squared minus 13x plus 3, right? And does this factor, or do I have to use a quadratic? Let's see here, 4x, x, 1 and 3, I think, maybe. 1 and 3 minus. Let me think about this. 4x squared, 12. Yeah, that works. Okay, so that means x is either 3 or 1/4. And I believe that's it. In a psychology experiment, an image of a cat or an image of a dog is flashed briefly onto a screen, and then Anna is asked to guess whether the image showed a cat or a dog. This process is repeated a large number of times with an equal number of images of cats and images of dogs shown. If Anna is correct 95% of the time when she guesses dog, and 90% of the time when she guesses cat, determine the ratio of the numbers of times she guessed dog to the number of times she guessed cat. So 95 for dog and 90 for cat. Okay. All right, so let's talk about this here. Oh boy. Which direction do I go here? Okay, so let's just make it one step at a time here. Otherwise, it might get a little overwhelming. So cat is 90% of the time guessed correctly, and dog is guessed correctly 95% of the time. Okay. And then the cat being shown, let's talk about that. When a cat is shown, she guesses cat, or guessed cat. Let's refer to that as C. And she guessed dog, so that would mean she guessed incorrectly. Let's call that 100 minus C. And let's just say let's just give some numbers here, because it makes it easier if you give numbers. Let's just say it's shown 100 times. Well, then this means that since we are talking about 90%, that means that she guessed cat, and she's correct 90% of the time. So of all the times she guessed cat, yeah, this statement really needs to be understood. 90% of the time when she guesses cat, she is correct. So in this category, 90% of the time, which would be 0.9c, she is correct. So that's why I put C for cat. And then the other 10% of the time, which would be 0.1c, she guessed dog, and therefore she was incorrect. So it's a little bit, it's not really, takes a little bit of understanding because you can probably go in the wrong direction very quickly. Okay, so let's apply the exact same logic to the dog scenario. So the dog scenario, let me just move this over here, get a little bit of space. So the dog scenario is a dog shown, and it says the same amount of times, right? Equal number, of images. Okay, so we can use the 100 again. All right. So dog shown, let's just say 100 times again. And then guessed dog. She guessed dog. And then she guessed, I don't even know if I'm spelling guessed properly here. And guessed cat. Okay, so now, what are we going to use? We're going to use D. Yeah. So this is D, and this will be 100 minus D. And then very similarly, because we're talking about dogs now, if she guessed dog, she's correct 95% of the time. So that means 0.95% of the time, which is 0.95D, that she would guess dog. And then the other time, which is 0.05D, she would have actually, it actually would have been a cat. So that means she was incorrect. Okay, so now we can, after we've done all that, now we can look at the total images of cats. The total images of cats is this guy and this guy. So that means 0.9c plus 0.05d. That's the total images of cats. And then the total images of dogs will be that and this. So that's 0.1c plus 0.95d. Correct? Okay, so now we can finally make our equation. Remember previously that the number of images is equal. The number of images of cats shown and the number of images of dogs shown is equal. So that means this is equal to that. So 0.9c plus 0.05d is equal to 0.1c plus 0.95d. So let's do this math here. Let's put everything, let's combine like terms, and that'll make this 0.8c and 0.9d. And therefore, if you put d over c, you get 0.8 over 0.9. And that basically means that d over c is 8 over 9. And I think that is what they wanted. The ratio of the number of times she guessed dog to the number of times she guessed cat. So that's basically d over c. And that's exactly what we got. So that's 8 to 9. Suppose that x and y are angles with tan of x equal to 1 over m, and tan of y equal to a over n for some positive integers a, m, and n. Determine the number of positive integers with a less than or equal to 50, for which there are exactly 6 pairs of positive integers mn with x plus y equal to 45. And they give you a very nice trigonometry identity, which I'm positive is going to help in this question. Otherwise, they would not have given it. So I'm going to immediately use it and see what happens. So here we go. Now let's see what we can get. So to x plus y, they told me is 45. So let's just put that right there, 45. And then tan of x, according to the information they gave me in the question, is 1 over m. Tan of y is a over n. And then 1 minus tan of x, which is 1 over m. And then times a over n. Okay, so there's the substitutions. Now let's go with this math here. Tan of 45 is 1. And you can easily figure that out. And then I've just got to do this whole adding fractions and all that stuff. So let's do that, going back to your adding fractions. So this is going to be n plus am all over nm, and then all over, oh boy, mn, and this is 1 over 1, so mn, so this is going to be mn minus a. Yeah, mn is minus a over mn. Okay, so when you invert and multiply, I think the nm's go, meaning you can cross them out. So then that just leaves me with n plus am over mn minus a. Okay, so that's about as far as I can go there. Hopefully I've done that right. Now where do I go from here? Well, let's cross multiply. And then we get this. And then there's a lot of variables here. So this, you need the same number of equations as variables. So since there's, 3 variables, you'd need 3 equations, but we only have 1 equation. So we're going to have to do some guessing, inspection and all that. But I think it will help if we factor it. So this is where sort of the fancy algebra comes in. If I add an a to both sides, I can probably factor this. So let's see what happens here. This, let me think about this. Actually, let me put everything on one side first before I do that. Let's see here. And then put that a over and then add a to both sides. I think that would probably be a little bit better to do it that way. Yeah, this will probably be a little bit better. Now let's see, this becomes 2a. And this now can be factored. N minus a, and then minus n minus a. Okay. There's a little bit of thinking there. And then this can be factored even further, n minus a, and then m minus 1, I believe. And that's 2a. Okay. So that is about as far as I can go there. Okay. All right. So that's pretty decent, I think. And then they gave us some parameters about a, that it's got to be less than 50. And a is also an integer or something. Let's see here. It's positive integer. So that means if it's a positive integer, it's got to be at least 1. So it's between 1 and 50 inclusive. So that really helps, I think. All right. So now let's see what we can get here. All right. Well, before I tackle this, let me see what I can do here. For the other letters is what I'm saying. Well, a has to be positive, so a cannot be 0. So because a cannot be 0, m cannot be equal to 1. And also n minus a cannot be equal to 0, so that means n cannot equal a. And since a is a positive integer, n would have to be greater than a. And m would have to be greater than 2. Greater than or equal to. Are they also integers, n and m? Yeah. And positive integers, a, m, n. Okay, so they're all positive integers. Got it. Okay, so this is just some parameters, or that I think will help us. It's always good to have some boundaries, otherwise it makes it easier. Okay, so now let's make a table and let's see what we can do, because we got to work with this guy here. And we want 6 pairs mn. 6 pairs. So we have to figure out what form that 2a is going to be, this 2a. Okay, so that's the first sort of question. And then if the 2a has 6 divisors, I think that's the only way it could work. And I'll explain this. And then we're going to actually look at what those divisors are, positive divisors. Yeah, I think so. And then, of course, we'll have to just then figure out what is A. What are the values of A? Values of A. Okay. All right, so yeah, I think that's pretty much a good table. And before I get into it, I've got to explain a thing. You guys may have already known this, but it's helpful to explain. Let's say I have 5 to the power of 2 and 7 to the power of 3, right? And I said to you, how many divisors does this have? Well, you can do it manually, which would take a long time, especially if these numbers get very big. Or there's a trick. You take this and you take this, and you do 2 plus 1, which is this 2, plus 1, times this number, plus 1, and that's the number of divisors. So this would be 3 times 4, so 12 divisors. So let me give you it in terms of letters. You have a prime number, p, to the power of a. You have another prime number, q, to the power of b. The number of divisors would be a plus 1 times b plus 1. Okay, some of you may have already known that, but it's worth kind of reviewing. Okay, so now we want to concentrate on this guy, the form of 2a. It could be p to the power of 5, meaning you have a prime number to the power of 5. Or it could be p to the power of 2 times q to the power of 1. And I think, for now, I think that should be good enough. Yeah. And if it isn't, we'll touch on it later, because I can't think of any other ways. Because let me explain why. This is where this whole thing comes in. I explain this for a reason. Because if it's p to the power of 5, the number of divisors would be 5 plus 1, which is 6. Right? Exactly what I did over here. If it's p2q1, the number of divisors would be 2 plus 1 times 1 plus 1, which is 3 times 2, which is 6. And that's what we want. That's exactly what we want. So that fits. And now we got to figure out what are those positive divisors in terms of the numbers. Okay, so let's work with the first one. If p is a prime, so let's start off with the smallest prime, because remember we have a parameter for a, and that's very helpful, because otherwise it'd be infinite. Let's start off with p equals 2. If p is 2, then p to the power of 5 would be 2 to the power of 5, correct? Which is 32. And 32 is representing 2a. So that means a is 16. And I believe that takes care of that one. So that's really good. Okay, now we gotta find several more though, because they want how many total number of values. Okay, so now before I move on, let me just see if that is all there is to that story there. And I think the answer is yes. Okay, so let's move on. But I'd like to keep all this in the same page here, and I think I can. Yeah, okay. Now let's talk about this guy. This guy, let's say p is 2. If p is 2, then what do we have here? We have 2 to the power of 2 times q is equal to 2a. So that means 4q is equal to 2a. That means a is equal to 2q. Now q is a prime number, correct? These are both primes. So I've got to find values of a that are 2 times a prime number within that range. So the primes are, like, q cannot be 2 because I let p equal 2. They're 2 different primes. So values of Q are 3, 5, the prime numbers are 7, 11, 13, 17, 19, 20, 20, 23. Correct? And then, therefore, A would be 2 times that. So we'd have 6, 10, 14, 22, 26, 34, 38, and 46. Now you might say, well, why didn't you keep going? Because I've got to abide by that parameter. It cannot be above 50. So these guys are part of my list. And so there's 1 there, and I think I just got 8 there. Okay, so we're almost, I think, done. I think we just have one more scenario, and that is, here I chose P equals 2. The next one I'm going to choose Q equals 2. If Q equals 2, then what scenario do I have with this guy? Then that becomes 2P squared, I believe, is equal to 2A. So P squared equals A. So if P squared equals A, and P is a prime, then A would be the square of a prime. So 3 squared, which is 9, 5 squared, which is 25, 7 squared, which is 49, and that's it. After that, we would be above 50. So then we got these guys. So let's add them all up. We got 1, we got 8 here, we got another 3 there, so that's a total of 12. So 12 values of A is what we get for this question.